In the deepest silences between the stars, there exists a coldness and a dark, so profound they defy human comprehension. This is the interstellar void, a realm once thought to be almost perfectly empty. It stretches for light years, a silent ocean separating the bright islands of solar systems. Yet we are beginning to learn that this great emptiness is not truly vacant. Phantoms drift through its Stygian expanses. These are not ghosts of light or memory, but worlds of substance and gravity. They are nomads of the cosmic night, unmoored from the warmth of any parent sun. For centuries they were purely theoretical, a whisper in the equations of astronomers. Now, with a new eye gazing into the infrared spectrum, we have finally seen them. The James Webb Space Telescope has parted the curtain on a staggering, unexpected sight. Humanity's most powerful observatory has uncovered hundreds of these lonely wanderers where none were thought to exist. And they are not alone. They are traveling in pairs. Our story begins in a familiar celestial landmark, a glowing jewel in the winter sky. The Orion Nebula is a stellar nursery, one of the closest and most active cradles of creation to our own world. Visible to the naked eye, as a fuzzy patch in Orion's sword, it is a place of breathtaking violence and beauty. Within its turbulent clouds of incandescent gas and obscuring dust, new luminaries are being forged. Massive, brilliant young stellar bodies unleash torrents of radiation that carve out vast caverns in the surrounding material. Imagine a cosmic metropolis in the throes of a chaotic creative frenzy. Protostars ignite within dense cocoons, their nascent gravitational fields wrestling with one another. Stellar systems form in a crush of activity, a gravitational mosh pit where celestial bodies are constantly interacting. Planets coalesce from spinning disks of debris, their early lives defined by instability and peril. This maelstrom is the perfect environment for cosmic calamity, a place where a young world could easily be cast out from its home. Into this vibrant and tumultuous region, the Webb telescope directed its golden mirror. It peered deeper than ever before into the nebula's glowing heart, past the veils of dust that blind other instruments. The observatory was not hunting for stars, nor was it searching for galaxies. It was seeking out the faintest, smallest, and coolest objects that hide within the stellar forge. What it discerned there has sent a shockwave through the astronomical community. The infrared gaze of this incredible machine revealed something that shouldn't be possible, according to our neatest theories. Scattered throughout the trapezium cluster at the core of the Orion Nebula were dozens upon dozens of curious objects. They were far too small to be stars, lacking the mass to ignite the fires of nuclear fusion. Yet they were also untethered, not orbiting any stellar parent. Most astonishingly of all, a significant number of these free-floating orbs were found in binary pairs gravitationally bound to one another as they tumbled through the void. Scientists have given these newfound spectres a name: Jupiter mass, binary objects, or jumbos. The designation captures the essence of their enigma. Each component of a jumbo pair has a mass comparable to our own solar system's largest gas giant. They are planetary in scale, yet they drift through space like miniature starless solar systems. Webb's initial survey catalogued over 500 of these free-floating planetary mass objects, with roughly 80 of them locked in these strange binary partnerships. This was not a rare anomaly. It was a prevalent feature of the nebula. The discovery presents a profound puzzle that strikes at the very heart of how we believe celestial bodies form. Our models of creation have two primary pathways for cosmic objects. Stars are born from the top down when enormous clouds of gas and dust collapse under their own gravity, growing hotter and denser until their cores ignite. Planets, on the other hand, are thought to assemble from the bottom up. They accrete material bit by bit within a protoplanetary disk, that swirls around a young central luminary. A planet by this very definition requires a sun. These jumbos shatter that clean distinction. They are the size of planets, but they have no star to call their own. They drift in the dark, locked in a silent dance with a twin. How could such a system possibly come to be? The existence of these pairs in such numbers challenges our fundamental understanding of both planetary and stellar formation. Two main competing narratives have emerged from the scientific community, each attempting to explain this cosmic riddle. The first hypothesis is one of violent expulsion. In this scenario, the jumbos are true orphan planets. They were born in the conventional way within the swirling disk of gas and dust around a young star, just as Jupiter and Saturn were. Their early lives, however, were spent in the brutal chaos of the Orion Nebula. In a densely packed stellar nursery, gravitational encounters are frequent and fierce. A close pass by a sibling world or a neighboring stellar body could have provided a powerful gravitational kick. This cosmic slingshot would have been strong enough to overcome their parent sun's gravity. The young worlds were flung out of their home systems, ejected into the lonely darkness of interstellar space. This theory neatly explains the existence of single rogue planets, which astronomers have long suspected to be numerous, but it struggles to account for the binaries. How could two planets be ejected together and remain bound to one another when the very forces ejecting them are so disruptive and chaotic? For a pair to be thrown out as one, the event would have to be exquisitely fine-tuned. Imagine a cosmic billiards shot of impossible precision. Two worlds would need to be in just the right place at the right time. A passing star would need to perturb their orbits in a way that sends them both careening out of the system, but without ripping them away from each other. While not impossible, the sheer number of jumbos found by Webb makes this scenario seem statistically unlikely. The universe would need to be an uncannily perfect shot to produce so many of these paired exiles. This leads us to the second and perhaps more radical explanation. This idea proposes that jumbos are not ejected planets at all. Instead, they may have formed exactly where we see them, directly from the nebula's gas and dust. They would have been born not like planets but like stars. According to this model, small dense pockets within the molecular cloud collapsed under their own weight. This is the standard mechanism for stellar birth, just scaled down to an impossibly small size. These collapsing clouds, however, never accumulated enough material to trigger hydrogen fusion. They failed to become true stars, settling instead into existence as colossal gas spheres glowing faintly with the residual heat of their own formation. This process could more easily explain the binary pairs. Binary and multiple star systems are incredibly common throughout the galaxy. Our own sun is something of an anomaly for being single. It is thought that the initial collapsing cloud of gas often fragments into two or more cores, which then evolve into a gravitationally bound system. If jumbos are born from this scaled-down stellar process, then their twinned nature is no longer a surprise. It would be an expected outcome. But this failed star hypothesis comes with its own monumental challenges. It pushes the known physics of star formation into uncharted territory. Our theories suggest that there is a lower limit to the mass a collapsing gas cloud needs to form even the smallest of objects, a threshold known as the opacity limit. The components of these jumbos appear to be well below this limit. If they did indeed form like stars, it means our understanding of how gas clouds fragment and collapse is incomplete. There may be a third path to creation, a previously unknown mechanism that operates at the blurry boundary between what we call a planet and what we call a star. These objects might represent an entirely new class of celestial body, one that belongs to neither category. They are not quite planets and not quite stars, but something else entirely. To unravel this mystery, scientists are turning back to the remarkable instrument that made the discovery. The James Webb Space Telescope is more than just a camera. It is equipped with a suite of powerful spectrographs. These tools can capture the faint light from a distant object and split it into its constituent colors, creating a chemical fingerprint of its atmosphere. By analyzing the spectra of these jumbos, astronomers hope to find clues about their origins. If they were born in a protoplanetary disk and later ejected, their atmospheres should be rich in heavy elements, or metals in astronomical terms. These heavier materials, like carbon and oxygen, are concentrated in the disk close to a star where planets form. Conversely, if they formed directly from the collapse of a pristine nebula gas cloud, just like a star, their atmospheres should be composed almost entirely of the primordial elements hydrogen and helium. The atmospheric composition is the smoking gun. The data from Webb spectrographs will be the deciding evidence in the case of the ejected orphans versus the miniature failed stars. Each spectrum painstakingly collected from these incredibly faint and distant objects will add a piece to the puzzle. What we learn will either reinforce our current models of cosmic creation or force us to tear them up and start again. Either outcome represents a profound leap forward in our quest to understand the universe. The implications of this discovery extend far beyond the Orion Nebula. If so many of these rogue worlds can be found in just one small nearby patch of the sky, it suggests that the Milky Way galaxy could be absolutely swarming with them. For decades, we have been taking a census of the cosmos by counting the things that shine stars and galaxies. But what if the majority of worlds are dark? Some calculations suggest there could be 20 times more free-floating planets than there are stars in our galaxy. Think of it. For every point of light you see in the night sky, there could be dozens of unseen starless worlds drifting silently through the abyss. Our galaxy might be a far more crowded place than we ever imagined, its dark highways filled with these wandering orbs. This realization forces us to reconsider the very nature of our cosmic neighborhood. The universe is not just a collection of brightly lit solar systems. It is also a vast, dark wilderness, populated by nomads. This finding also reignites a long-standing debate about definitions. What fundamentally is a planet? The International Astronomical Union currently defines a planet as a body that orbits a star, is massive enough to be spherical, and has cleared its orbital neighborhood. By this definition, these jumbos are not planets. But this feels like a failure of language, not of physics. A world with the mass composition and character of Jupiter is, for all intents and purposes, a planet, regardless of whether it has a sun. Perhaps we need a new classification, a new branch on the celestial family tree. We may need to think of planehood as a state of being defined by an object's intrinsic properties, its mass, its geology, its atmosphere, rather than by its location or its relationship to a star. These lonely travelers are forcing us to be more expansive in our thinking, to recognize that the cosmos is more creative and varied than our neat little categories have so far allowed. And then there is the most tantalizing question of all. Could such a world bereft of the light and warmth of a sun possibly harbor life? At first glance, the notion seems preposterous. Without a star, there is no photosynthesis, no stable source of energy to drive the complex chemistry of biology. The surface of such a world would be frozen at temperatures barely above absolute zero, encased in a permanent starless night. Yet life can be tenacious. Here on Earth, we have discovered ecosystems that thrive in total darkness, clustered around hydrothermal vents on the ocean floor. They draw their energy not from the sun, but from the chemical reactions fueled by the planet's own internal heat. A massive gas giant, especially a young one, would have a tremendously hot core, a leftover furnace from its violent formation. Could a rocky moon orbiting a rogue Jupiter be warmed from within, sustaining a liquid water ocean beneath a thick crust of ice? It is a deeply speculative idea, a whisper of a possibility on the farthest frontiers of astrobiology. The chances may be slim, but the discovery of jumbos proves that the galaxy is filled with environments we are only just beginning to imagine. Life might not be confined to the sun-drenched shores of terrestrial planets like our own. It might also find a way in the deep, dark, wandering oceans of these orphaned systems powered by the embers of planetary creation. The ongoing study of these objects promises to be one of the great adventures of 21st century astronomy. Each new observation from Webb will add another brushstroke to our portrait of these enigmatic worlds. We will learn their temperatures, their atmospheric chemistry, and the velocities at which they are tumbling through the Orion constellation. We will build a more complete census determining just how common they are and whether they prefer to travel alone or in pairs. This investigation is about more than just understanding a new type of celestial object. It is a profound exploration of our own cosmic origins. The same processes that governed the formation and fate of the jumbos were at play in our own solar system's infancy. The same gravitational chaos that may have ejected them is what ultimately shaped the stable, life-bearing architecture of our planetary family. By studying these outcasts, we gain a deeper appreciation for the delicate chain of events that allowed our own world to form and flourish. We stand at a precipice of discovery. The universe, it seems, is far stranger and more populous than we knew. It manufactures worlds with a startling profligacy, not only in the cozy confines of solar systems, but also in the wild, untamed darkness between them. It binds them into pairs, sending them on journeys that will last for eons, their paths crossing the galaxy in silent, majestic arcs. The image of two dark worlds, locked in a gravitational embrace and sailing through the eternal night, is a powerful and humbling one. It reminds us that our understanding of the cosmos is a flickering candle in an immense unlit hall. With every new discovery, the darkness recedes just a little, revealing wonders more intricate and astonishing than we could have ever predicted. The jumbos of Orion are a testament to this truth. They are the unexpected children of the cosmic dawn, a mystery written in the cold and the dark, waiting for a curious gaze to finally bring them into the light.